Hello friends, in this video we'll see how we can measure the distance between 2 points, or we can measure a distance of an obstacle. So for this we'll be using an ultrasonic sensor which uses ultrasound to identify or to get the distance of the obstacle. So before jumping in, let's see what are the components required for this experiment. So we need one breadboard, then we need an Uno, we need one ultrasonic sensor, and then we need 4 jumpers. So these are the required things what we need in order for this experiment. Now before starting the hardware, let me explain you how this ultrasonic sensor works. So your ultrasonic sensor has two major things. One is a transmitter and another one is a receiver. So your transmitter is used to transmit the ultrasonic and the receiver is to receive the ultrasonic waves. So what happens is, in transmitter we have to transmit an ultrasonic for maybe 10 microseconds. So once we send a 10 microseconds delay, so there is an 8 cycle ultrasonic wave created. So this wave, when it hits an obstacle and it comes back, so that is received by a receiver. So the next question is, how do we calculate distance from an ultrasonic? So what happens is, it measures the time. Yes, the time required from here sending to back receiving. So if this is the t time, what we receive is 2t. That is nothing but the time that it goes from the starting to obstacle and the time from obstacle hitting to coming back the receiver. So from that time and from a few formulas, we can calculate the distance in centimeter or in meters. So we'll be seeing how we can do that. So these are the sensors what it is required. So now starting with the hardware. So this is the ultrasonic sensor what we have. So we can place it on this breadboard. So this has 4 pins. One is VCC, one is ground, and then 2 pins. One is trigger which triggers the ultrasonic, and another one is the receiver which receives. So here VCC will go to 5 volt. So VCC goes to 5 volt. Trigger pin will go to pin number 9 of Arduino. Echo pin will go to pin number 10 of Arduino. And as usual, ground pin will go to ground of Arduino. So let me quickly color the wire so that you guys don't get confused. So this is going to ground, as you can read it here as labeled here. Then this is VCC, so I'll color this red. Now then trigger pin, I'll color this yellow, which goes to pin number 9. And then echo pin, which goes to pin number 10, I'll do it in color. Yeah. So this is the connection. So pretty much simple connection. VCC ground is pretty much there for all the sensors. Extra thing we have here is trigger and echo. So this is with respect to the hardware. So same thing we will be doing it here. So I have my ultrasonic sensor, which I'll be placing it here. Now once I'll see I have VCC, so I'll take VCC and place it in 5 volt. Then next I have trigger, so I'll be using an orange wire right here, placing it trigger. So a trigger, according to our diagram, we have placed it in pin number 9 of Arduino. Then echo will be placed in pin number 10 of Arduino, and after that we have ground, which will go to Arduino's ground. So this is pretty much simple and basic connection. So now once we have finished this hardware connections, now with the software part, that is the code, so we do not have any library or anything included. All we have to do is write a program to trigger the echo trigger pin, and then for 10 microseconds, and then after that receive it. So first I'll go and quickly declare two pins. So I'll say int trigger pin, that will be pin number 9 what I have used here, and then I'll give int echo pin. So according to my pin diagram, it is pin number 10. Yes. Now what I can do is, in void setup, I'll first start serial.begin. So I can start serial communication so that I can display the value. Now after this, I'll give pin mode. I have to specify whether my trigger pin is input or output. So my trigger pin is output because it will trigger few ultrasonic sensor based on some voltage, and then my echo pin is input because it will read the current, or it will read the voltage what it is being fetched to it. Yes. Now in the loop part, we will digital write trigger pin comma low initially. Yes. And then we'll use a function delay microseconds. So this is the function we can use to give in microseconds. So 2 microseconds I'll wait. Now after that, so what happens, this clears the trigger pin. This clears the trigger pin. Now after clearing, now I will start triggering. So now I will set trigger for 10 microseconds. So now for 10 microseconds, I'll put this as high. So what I'll do, I'll write digital write, and then I'll say trigger pin comma high, and then I'll give a delay in seconds, microseconds for 10 microseconds. Then after that again I'll give digital write, then I'll say trigger pin comma low. So what happens, it will be high, and for 10 seconds, after 10 seconds it will be low. That means I'm triggering this high for 10 seconds. Now after that I have to read this, right? So I'll say int of duration is equals to, I have to use this inbuilt function, that is pulse in, to read the pulse for echo pin, and I'll give high. That means it has to read the input. Now after that I'll use this duration, and then you have one formula what we have to use, that is multiply by 0.034 divided by 2. After doing this, simply you can print it. Serial.print, then I'll say distance, then I'll say serial.println, then I'll give this duration, sorry, it will be int of distance, my bad, this is different value. Now distance, and then I'll give serial.println centimeter. So in centimeter it will be displayed. So this is all the program you have to. So read the pulse. So this is the program what we have to write in order to read the trigger. So now that our software part and hardware part is done, so now we can quickly go and power up the Arduino and upload the program. So now I have powered the Arduino. So now we'll quickly upload the program. So we'll reconfirm the board and port. So yes, board and port are selected properly. So now I'll go and upload the program. Okay, my bad, typo mistake, it's echo pin. Okay. So it's compiling the sketch. Okay. Now it is uploading, done uploading. So now I can go to tools. I can click on serial monitor. So you can see now there is a distance. There is actually it's measuring an obstacle at 19 centimeter. That is nothing but my laptop. So I'll just place this bit far. So you can see now I'll give my hand as obstacle. You can see there is a 15 centimeter gap between this and my hand. So as and when I get my hand closer, so you will see that the distance is reducing. You can see 7 centimeter, 6 centimeter. Now as and when I increase, you see the distance is increasing. So you can use this ultrasonic sensor in order to measure the distance of obstacle.